In this video, I want to talk to you a little bit about the topic of probability. Probability used to be a topic that I covered quite a bit. I don't need to do it as much as I used to because probability is tied into a lot of the calculations we're going to do. And we don't do those calculations anymore. We let the computer do it. So the main topic that I want to cover is when we're looking at a little table like this. I'll call this a two-way table because there's two variables, the year in school and whether a student is employed or not. And I have a breakdown of how the 329 students sampled fell into those different eight kind of combinations. 16 were freshmen who said yes, they were employed. 131 were sophomore. And you can read the rest of the numbers. I had 329 students. And what I want you to be able to do is answer basic questions about this table. And you can see that the answer was bouncing in there. But let's talk about it first. What proportion of my students are upperclassmen? And so first thing you have to understand is what an upperclassman is. And typically an upperclassman would be juniors and seniors. And so what I'm asking is how many of my 329 students are upperclassmen? And you can see it was just bouncing in. There it is. I'll let it go this time. I'm going to say there's 126 out of the 329. 102 that are juniors and the 24 together, that makes up 126 out of 329. I mentioned I want to show you how to read these tables. I didn't mention it was going to be difficult, did I? This is pretty straightforward stuff. Now, sometimes the questions get a little bit more challenging, but never really challenging. So let me ask you another one. So same table. Now let me ask you this question. And again, I'm having trouble moving ahead here. Find the probability a randomly selected student has a job or is a freshman. So let's see, here are the yeses, right? There's 246 of them. And let's see, or is a freshman. That or word there, that means either or. As a freshman, 28 are freshmen. And so one thing you could think about doing is adding those two numbers together, the 246 and the 28. However, you got to be careful because these 16 would be counted twice. Really what I want you to do is include all the observations in this row and this column, but you won't just add the 246 and the 28. You want to include these guys here. You want to include these here. If I could draw a box around it to make it even better, I want to include those there. That's the 246, but I want to add 12 to it. And so it's either 246 and 12, or you could do, let's see, 28 and 131 and 81 and 18, or you could do 246 and 28 minus the 16 you added in twice, but somehow you got to get to 258 out of 329. You could say it's all 329 and then take these guys out. A couple different ways of getting there. Now, if you think about it, the last problem was really an or problem too, right? Because I asked about upperclassmen, juniors or seniors. Why could we just add those two numbers together? Remember, we took the 102 and the 24 and we added them together because there was no overlap between them. There was no what we would call intersection. These 16 appear in both categories here. They both have a job. They're both yeses and freshmen, and so you can't count them twice. The or questions, those are typically referred to as unions. And sometimes in textbook homework problems, you'll see this. The probability, they'll ask for the probability of two outcomes, and typically we call those things A and B. If you want the union between them, typically you see this symbol. Now, I'm never going to give you that symbol because no one ever calls me on the phone and says you or uses a you symbol. I'll use words like or. Find the probability of this happening or that happening, but you may see this symbol with some homework problems sometime in a textbook. I just want you to be aware of it. That's the probability of the first outcome happening, that they, in this case, they have a job, or they're a freshman, or both. And so you want to take a look at it. In the last example, let me go back here. The probability of junior or senior, well, there was no overlap or what we call intersection because you can't be a junior and a senior at the same time. In this problem, you can be employed and a freshman. That's why you have to be careful. So the or question, you just have to be careful not to add in the intersection part twice. All right, let's take a look at another one here. So there's my little table. And I can't do this. Sorry about that. What proportion of my students have a job and are juniors? That's the intersection. And the symbol that you'll see used for the intersection, the U makes sense, right? If you think about a union, you think about an intersection or a union, it's a U. Well, here we have these two outcomes, and we'll say they have a job, the yeses, and are juniors. For whatever reason, statisticians can come up with a number symbol, so they or another symbol for the intersection. I, right? Union U, I would have made sense. So what we do is we turn the the union upside down, and the upside down U refers to the intersection. Again, you won't see me use these symbols. You might see them in textbooks, so I just want to give them to you here in the video. But the and means both categories or both outcomes have to occur. So let's see, have a job, that's a yeses. So I'll go down this row. Juniors, that's this column. Which ones have both characteristics? Those 81 out of the total of 329. So let's bounce that in. What proportion of my students are sophomores and don't have a job? Well, that one. What proportion are sophomores or have a job? Now I'm going to take a look at this column and that row, the ors. I got to be careful though, because these guys are counted both times. So you got to obviously know whether you're working with an and problem or an or problem, a union or an intersection. Definite difference between them. In the one case, you need both categories. That's the ands, that's the intersection, and the other, the or, the unions, you need one or the other or both. And so you have unions, you have intersections. All right, let's take a look at another example. So, given that a student works, what is the probability they're a senior? And this is a good time, especially this problem. This is the one that always makes me think of this. This is a good time to talk about formulas and equations. There are, for the union problems, there's something called the multiplicative law of probability. And if you look in the textbook, you'll see that the probability of A or B is the probability of A plus the probability of B minus the probability of both A and B, which is really me going through that conversation with you I just had and saying it's the probability of this one plus the probability of that one, but don't add in those intersections twice. It's subtracted out. And so you can always go and find a formula. And this is another type of problem called a conditional probability problem. And if you want to look, again, there's a formula. There's a probability of A given if B has occurred. What's the probability of A and B over the probability? There's formulas that you can look. However, keep it simple. Try to keep it as simple as possible. If I'm telling you, it's called conditional probability. If I'm telling you this condition is met, given that a student works, okay, what does that tell me? Does that tell me, well, it tells me the yeses, the row that we're in, right? We're in the yeses. And so what that allows me to do, once I know that the student works, once I know that information is correct, it allows me to ignore the rest. It allows me to go like this and say, I'm not going to look at any of this information down here. I'm just going to get rid of it. We're not interested in, oops, the nose. See if I can continue my scribbling out. I'm going to just ignore this part of the table. And so I'm only going to consider these 246. Now, of those 246, what's the probability they're a senior? 18. Real simple, real straightforward. That's called conditional probability. Given that the student is a senior, okay, now let's see if I can get an eraser here. Let's get rid of this stuff. Given that the student is a senior, let me get my pen back here. What's the probability they have a job? Okay, given that the student is a senior, different question. Given that the student works, what's the probability they're senior? 18 out of 246. But if I turn it around, probability, given that they're a senior, what's the probability they work? Well, now we're only going to consider these 24. I'm going to ignore the other columns. How many of those 24 work? It'd be 18 out of 24. This is called conditional probability. Another way of thinking about it is it restricts the group of, in this case, students, experimental units in general, but it restricts the group of students that you're looking at. In conditional probability, you're not going to consider all 329. You're going to consider just the part that you're working. If the student works, you're only going to consider 246. If you say given they're a senior, you're only going to consider these 24. Given they're a sophomore, what's the chance they don't work? Well, those are the two numbers you want, right? Given that they're a sophomore, here's my denominator. What's the probability they don't work? 44 out of 175. Conditional probabilities. Again, there's formulas you can look at if you want. You don't need to. Okay, keep probability simple. That's what I'm going to suggest to you. So take a look at those and see how you do.